I don't know if this is, oh yeah, it is recording. Okay. Okay, so the topic for today is modeling with just categories. And as I mentioned earlier, we've been having a number of discussions both internally and with clients about how this is done and why we do it the way we do. So this seemed like an opportune moment to dive deeper into how just categories work. So as an overview of the presentation, I'm going to first talk about the design and the high-level concepts. Then I'll go into implementation and nuts and bolts is sort of a level of implementation, a low-level implementation, things like file names that are not actually part of the conceptual implementation. I'm going to talk a little bit about taxonomies and control vocabularies and just comparison with scopes, and then there are a number of interesting open questions regarding categories, some of which we've discussed here at Semantic Arts, and I'm hoping we have time to get to those. So starting off with design, and here I'm going to talk about what a category is, how they differ from classes, instances, tags, and when you should use classes, one or the other. When is it appropriate to use categories?
Sorry, Rebecca, are you trying to share? I'm not sure if I'm the only one not
so understanding. Or... Sorry. Oh my gosh. Okay. Thank you for letting me know. Okay. Can you see it now?
Yes.
Yeah, we've got the slide tab up now.
So you didn't much. So I'm here. So the right, the design phase, we'll talk about the differences between categories, classes, instances, tags, and when it's appropriate or preferable to use one or the other. What is a dish category? That's the way we define it in scheme is a concept or label. So somebody's got some background noise. If you could mute. Thanks. So the definition of just category is the concept or label used to categorize or classify other instances informally. So categories are technically instances, but they represent concepts in the knowledge domain and are thus included in the data model as opposed to instance data, which is not included in the data model. So the general rule of thumb of excluding instances from the model doesn't apply to categories. Categories are instances that are used to define the model and the knowledge domain as a whole. So how do we use categories? They're a mechanism for assigning type to objects that differs from class membership. So an example is companies like LinkedIn and Indeed and Glassdoor have a large number of skills categories that they use to categorize people who have those skills and companies, professions, or projects that require those skills. Categories we can consider that they belong to groups of similar categories, which could otherwise be thought of as taxonomies or control vocabularies, which define different values along the same dimension. So for example, Linux, OWL, and phonology could all be categories in the skills vocabulary. So how do categories differ from OWL classes? This is pretty basic, and I should tell you that my graphic skills are pretty rudimentary. You'll probably notice that on your own, but just sort of an explanation of why I don't have a lot of sophisticated graphics. But as we all know, a class is a set of instances that share a common property. So an instance is a member of a class. So here are individual persons, and they all belong to the person class. All classes have formal semantics, so you can, alongside a human readable definition like Scott's definition, you can write axioms that formally define properties of that class, what can be a member of that class, and so on, which allow reasoners to draw inferences in the form of new triples. So, for example, a person can be defined as something that has exactly one biological mother. We call it a personality axiom. And all persons are living things. We call this a subclass axiom. So from both of these, you can derive additional data so that if John is a person, we also know that John is a living thing. Now, categories are instances, as I said, and we use them to classify other instances. So here we have these people that belong to a person class, and the orange rectangles represent categories that can be applied to those people. So Claire is categorized as an ontologist, Sharif is a Python programmer, and so on. Now, categories do not have formal axiomatic semantics, but they may have semantic relationships with one another. And the most common one we see is the sub and supercategory relationship. So, for example, the skill Python programming, the subcategory of the skill computer programming. And I'm going to discuss a lot more about these relationships as we go along. So the big question here is, when should I use categories and when should I use classes? The simplest rule of thumb is to keep things simple by using categories until there's a need for the greater expressiveness that classes provide. So for example, until you find that you need to say more about what it means to be an ontologist or have the skill of an ontologist, it's better to start out with these as categories. And then if later on you find out that you need to describe what it means to be an ontologist in more detail, or what kinds of relationships it has to other things, there's a formal mechanism that I will describe for migrating data from categories to classes. So categories are best when on the semantic level, they're buckets to sort things, but they don't really have other characteristics or semantics of their own. So for example, this doesn't tell us anything about what an ontologist is or what a mechanical engineer is. It just categorizes these individuals with one of those categories. There's a governance issue. Often we have vocabularies that are maintained by taxonomists or subject matter experts rather than the ontologists. So we would like to cordon off that part of the model for the purposes of independent governance. And there's an issue of quantity. When there are a large number of concepts, a taxonomy works best. Now, there's no hard and fast definition of what large means. I can't really say, but for example, 10,000 would be a large number for sure, and would not translate well to a class hierarchy. So in contrast, classes are best when you can differentiate the formal properties of the different concepts through axioms, as I discussed. And the governance, the vocabulary will be maintained by ontologists, and there are a relatively small number of concepts. And again, if you start with categories and find that you actually do need the greater expressiveness and semantics that classes would provide, there's a way to migrate to classes with a formal definition of links, and I'll show you how that works later. So let's look at how categories differ from instance data. So categories are instances. But when I say instance data, I'm talking about, you know, individual people like Doug and Peter. So categories, as I've mentioned, have semantic relationships only to one another and the objects they categorize. We'll discuss a few exceptions to that later. And they belong to a closed or curated set. Instance, so for example, if Indeed, excuse me, if Indeed is developing skill categories, those are heavily curated by the taxonomists at Indeed. They're not just, it's not just a free-for-all where anybody can throw anything in that they want to. Whereas instance data is open-ended. You know, the class of persons is just who they are. Persons are persons. Nobody is curating that set to say who's a person and who isn't. And they can have a variety of attributes and relationships to other instances, which we'll see again later. So when should you use categories and when should you use instance data? So let's take an example of nationalities. If I just want to use nationalities to categorize people by nationality, I can simply use the categories German, Swiss, Austrian, etc. That would be enough to link a person to a nationality. But if I need to model a variety of information about the countries, such as population, official language, the area, the currency, the location, and so on, I would define a class country with instances, data, like Germany, Switzerland, Austria. And we can still indicate the nationality by relating persons to those country instances, but there's greater versatility because these persons can have a variety of different relationships to the countries. For example, resides in, was born in, is citizen of, and so on. So rather than just say, you know, Claire is categorized with French nationality, we can say more about where she lives, where was she born, where is she a citizen, when I have France as an instance, as a piece of instance data. Now, looking at tags and how categories differ from tags, the word tag is not really well defined. It means different things to different people, but a common usage of the word tag is free-form text that people use to label things. Sometimes that's sort of can be user-driven, so users are allowed to put tags on things. They perform similar functions, but categories, again, form a controlled vocabulary. And in general, you prefer controlled vocabularies over free-form text in most situations. So if Indeed is putting together a list of skills, you know, it doesn't want variations like singular, plural, or different spellings or different capitalizations, because you're not then able to say this is all the same skill. So if you use a controlled vocabulary, you can say this is one skill and, you know, it connects to various people. So those are the top level concepts. Does anyone have any questions before I move on to implementation?
Hi, Rebecca.
Hmm?
Sorry. So what's the difference between a category and a SCAS concept?
Yeah, I'm going to get to that. Good question. That'll come a little later.
Thanks.
So we're going to use some categories. We've decided to use some categories in our model. So how do I define them? How do I relate them to the objects they classify? How do they relate to one another? And then I'll show you that JISP itself has some built-in category classes.
Excuse me.
Yeah.
Yeah, the question, what, I understand the benefit of maintaining control of vocabulary separately from ontological classes, but what is the benefit of not transforming, SCOS definitions directly into classes? What's the advantage of using categories in a basically OWL system?
Well, again, going back to when I would want to use categories versus classes, I talked about things like whether I need deep semantics or whether I'm just sticking labels on things. Who's going to govern these vocabularies? How many are there? It's not realistic to maintain a class hierarchy of 10,000 classes, for example.
But what's the cost of using classes in that situation?
The cost of classes. If I were to define these as classes, you mean? If I were to define my skills vocabulary as a set of classes? Is this what you're asking?
Yes.
Well, the cost could be you're creating a much more complex model than you need. You may create a governance problem because, for example, at Indeed, taxonomists are maintaining these vocabularies and they're not ontologists. They don't put classes into an ontology. Basically,
right. So I was saying you would have to be able to import categories as classes, but that's an easy transformation if you have them both in XML. So I don't see the governance objection really. I mean, that's okay. They maintain the vocabulary and then we can snarf it. We have to snarf it anyway in order to insert the category instances. So it doesn't seem to be much more label to insert the category minimalistic classes. It seems to me, maybe I don't understand, but in the category system, given that I am in the category Python programmers, the system doesn't know that I'm in the category programmers.
That's an interesting. I'm going to get to that actually.
Okay, great.
Yeah. Was it someone else trying to say something? Okay.
Somebody did put a comment in chat, which might be worth having a look at there, Rebecca.
Okay. Can you?
Yeah. And I also put my paw up.
Peter has his hand up.
Yeah. So the other thing is that people use the term facets, and I wondered if you had anything to say about that, Rebecca.
I will have something to say very briefly about facets. Okay. Was there someone else?
Someone mentioned that there's a comment in the chat, which is, I guess, the one I put. Like, I can just say briefly, so that people don't have to read it. Is essentially when we talk about you don't want to build a more complex model. That was one of your answers, Rebecca. So put it in category rather than class. And I think it's equally complex whether you put the hierarchy in the categories or in the classes. And one of my issues with category generally, to the extent I have issues with them, is that people sometimes think, oh, we just put like really complex things over in category and then we preserve this like austere, simple ontology. But it's just as complex if you're putting it in the category or you're putting it over in class. And we shouldn't deceive ourselves about like the fact that we swept it under the rug means that we have a much larger ontology.
I don't think we're slipping it under the rug. I think we are distinguishing cases where we need to attach more semantics to a category, to a concept, and where we don't. I think that's really the crux of the issue, other than the quantity. Well, the other considerations are quite serious. So I want to go back to an example Dave gave one time, and this is sort of what made the light go off for me. He was talking about gender, and which I know you're not really supposed to talk about, but anyway, it's always a very clear example. So he said, let's say you have gender male and female. So if you're in an HR system and all you want to know is somebody is, you want to check a box, are they male or are they female? You check a box and you don't care what that means. It has no meaning in the system. It's just a box you have to check. If you're developing a model of a medical system where, there are many different things you have to know about what it means to be female and male, only females go to obstetricians or gynecologists, and there are many other medical issues that differentiate males and females. So at that point, you would decide to have classes so that you can say more things about the individuals in those classes. But at the point where you're checking off a box, there's no need for any formal semantics. And classes without formal semantics are useless. In an ontology, we always aim to have formal semantics. Otherwise, it's just a vocabulary. It's exactly what it is. So in GIST, you'll find some classes that do not have formal semantics, but by and large, the goal is to have formal semantics because that's the point. Otherwise, you are just in the land of a vocabulary.
I'll just mention that I was filling out a lengthy form the other day and actually had 3 questions about gender. Social gender, gender assigned at birth, gender for insurance purposes.
Mhm.
So everything's more complicated than you think.
Yeah. I think I'll get to something that might help with that question later, actually, too. I'm gonna move on now. Okay, let's see. So we're going into implementation. How do I do this in GIST? So we have this class, GIST category, and I start by defining a subclass. I would generally define a subclass of GIST category. It's not very useful to just say I have a whole bunch of things in their categories. So we would start out by defining a subclass of GIST category. And in this case, I have a class called skill. I mean, yeah, a class called skill. I will note that GIST has a number of built-in category classes that you can use. I think of these, I've used aspect and product category. Those seem to be quite useful. I don't know. I don't have any experience with the other ones, but maybe other of our ontologists do. And certainly, you know, there's any number of possible category classes depending on your knowledge domain. So then we're going to define categories as instances of this class. So I'm defining a particular category, owl, that's the skill of knowing owl or doing owl, and it's a type of, sorry, this is not supposed to be just, whoops. That was not just skill, that's just skill in an unknown namespace. I have to fix that. And so I can give it a definition and pref label as usual. But you note it does not have any informal semantic structure. So then what do I do with it? I can link instances, data instances, to these categories. And the fundamental property that just gives us to do that is categorized by. So I can say this person is categorized by this skill and that skill. And I can relate categories to one another, principally with the notion of supercategory, which does give us a Scots-like hierarchical tree. So I can say the skill of Python programming has supercategory computer programming. I think this came up already, didn't it? Okay. And then I can use these categories to link instances together. So for example, Claire is categorized by, and I'm going to get, if you object to these predicates, I'll get there. So Claire is categorized by this owl skill. Semantic arts is in some way categorized by that skill. And that links them up together in some way. So, but what is the meaning of just is categorized by? It really has pretty vacuous semantics. All it means is this person is somehow associated with this category. So if you look at Claire, we wanted to say that she has this skill. And semantic arts, we wanted to say that semantic arts needs people with this skill. So using the same predicate is not very helpful because it doesn't tell you anything about what it means to apply that category to different kinds of objects. So I typically will define more specialized subproperties. So essentially I'm putting more semantics onto the relationships. So in this case, I've defined a subproperty of just as categorized by called has expertise. And so then when I apply that, and I have another one requires expertise. And then when I apply that to our individual semantic arts and Claire, we can see that she has this expertise. Semantic arts requires this expertise. And that's a much more sensible way of linking things together than just is categorized by. Now, we talked about how you would migrate from a category to a class. So I have this skill, owl. And let's say, well, I don't just want to know who has the skill owl. I want to know, I'm looking for an ontologist, which is more than somebody who just has a skill in owl. I want to define what it means to be an ontologist because, you know, as the HR person at Semantic Arts, I'm really not just looking for somebody with owl skills. I'm looking for an ontologist. So I define a class, ontologist, which is a subclass of person, and it has certain skills. So it's so what this saying is that it's a subclass of things that have the value, things that are categorized with the value skill owl. And I'm also looking for expertise in Sparkle. So, I see what this, sorry, this is a generated diagram. So what I'm saying here is an ontologist has expertise in OWL and it has expertise in Sparkle. And an ontologist is also someone who has read Michael's book on demystifying OWL for the enterprise. So that's how I'm defining an ontologist. So now Semantic Arts knows what to look for when they're looking for an ontologist. And this is a way of bridging a class to a new class that I want to define to an existing category.
I have a question, if I may.
Mm-hmm.
So you're subclassing ontologist on the person. Excuse me, I have a cold. And that suggests that the differential between ontologist and person is predicated on a skill and not on a physical specialization, or if it's an artifact, on a artifactually designed differentiation. So is that, I mean, you could certainly do this in OWL to say ontologist as a class is a subtype of person as a class, but from a perspective of ontology, you know, outside of OWL, would not the differentia that defines a taxonomy have to be more rigorous than what we see here, for example?
I think you're using a vocabulary that I'm not using, so I don't exactly understand what you're saying. But just to summarize again, what this says is an ontologist is a person who has skills in OWL and Sparkle and has read Michael's book. Now, obviously, this is not a real definition of, it's not a full definition of ontologist. This is just a fragment. So I'm not sure where you're finding a problem with this.
Well, what this is saying, this is expressing class membership, right? It's in terms of OWL, it's just saying that the entire class extension of person in this model as presented here subsumes the entire class extension of ontologist. And you can say that all the ontologist instances, or all individuals, if you will, are contained within the membership of the person class extension. And that's a set theoretic construct, and it makes perfect sense. From an ontology perspective, however, to say that what differentiates a person from an ontologist is based on what is implied here as the skill, and not something that is, for example, like in a Linnaean taxonomy, or say even, the differentiating between mammal and animal, right? There are physical constructs that are at a universal level substantively different or differentiable in mammal than there are in animal, and that's the basis of an ontological taxonomy.
Okay, so that's one type of relationship between, I mean, what RDFS subclass of is this triple that allows you to infer into a class. That's all it is. So ontologist is a subclass of person, literally means this. Anything that's an ontologist is a person. And anything that's a mammal is an animal. It doesn't tell you anything about how that subsumption, what's the nature of that subsumption. There's no commitment made. The simple relationship being expressed with subclass of is you say set subsumption. And they can be subsumed for any number of reasons. But if I point to any ontologist, I will find, at least according to this definition, that that is also a person.
Yeah, I agree with you with the set view, absolutely, 100%. Well, I'm suggesting though that an ontologist is a role. It would not ontologically be subsumed as a type under a person.
Okay, so you're talking, I think I know where you're getting what you're getting at, and you're getting at something that I actually will cover later, the notion of rigid classes. Classes, in other words, that are inherently part of objects versus classes that are role-based or temporary. If that's your concern, I will be talking about it later.
Thank you.
So this is just the turtle for what we see here. I'm not going to go over that. A few nuts and bolts. We have it in just some naming conventions. Interestingly, I should point out that we do not as yet follow the just naming conventions, but this is something we'll institute in the future. So we take the class and stick it in as an infix. It just makes, I mean, it's just for readability, right? It's just a convention. It has no semantic impact. And then we have the name of the instance with spaces and hyphens replaced by underscores, capitalization intact. You can find these conventions in our just style guide. So the interesting thing, and I think this might be what you were getting at, Anthony. So I say I take the class as an infix in the URI. Well, which class? So Claire is a person. She's a student. Let's say she's an ontologist. She's a mother. She's a number of other things. So what am I going to stick in there? And the answer is the most specific rigid class that the instance belongs to. And what is a rigid class? It's one that the instance inherently belongs to. You could say it's part of the essence of the object. And a nice way of saying it is that this object would not be the same object if it didn't belong to this class. And I say most specific because based on the subclass relationships in the hierarchy, we know that a person is a living thing, but the convention is to use the most specific one. So since person is more specific than living thing or physically identifiable object, we're going to use person. It helps us differentiate these, and also in the case of data ingest, it can avoid collisions in IRI collisions. So a non-rigid class is something that could be temporary or express a role or a relationship like these other ones you see here. So I'm wondering if that addresses what you were talking about, Anthony.
I understand what you're saying here. I respectfully disagree in terms of what universals mean, of how the classification or how the subsumption is modeled now between ontology and person. You know, universal is kind of like a mind-independent, repeatable representation of something in reality, for which all instances that instantiated are the maximal class extension. So, you know, you have. I guess what I'm saying is there's a role for, no pun intended. There's a role for ontologists as a role in an ontology. To say that it's a subtype of person is a conceptualization. It's a mental imprint on someone's view of how that should be related, you know, how the role of ontology should be related to the person in the form of the ontologist. And what happens when you have conceptualizations is you have these, you know, disparate independent views that conceptualize that, you know, someone else may conceptualize person being a subtype of ontologist. I see that often too. So now if you want to federate data models that have these,
Okay.
you know, yeah.
Well, we are kind of getting off track. I will say that I don't see how person could be a subclass of ontologist, and I will repeat that the subclass of relationship makes no claims about in what sense something is a subclass of something else. It strictly says anything in this class is also a member of the superclass of that class. No other semantic commitments being made. But I think we should move on. You and I can talk about this offline if you want to discuss it more.
Sure.
Could you paste a link to the GIST style guide into the chat?
Okay.
Google is not helpful.
Let's see.
And is there like an interoperability with potential other things, and then maintenance, say, of equipment type for people who are more equipment oriented folks versus facility type versus other things? Are there some aspects of who is the, quote, the domain experts and interoperability concerns?
Yes.
That might be another session. That's just a
Well,
question.
I mean, that was what I was talking about. If I understand you, that's what I was talking about with governance considerations. So sometimes we have a team of taxonomists governing a taxonomy. We have SMEs governing a taxonomy, or we have a combination of taxonomists consulting SMEs. So they're not typically the ontologists themselves, unless they're really part of the ontology model.
If it's a really big organization and, you know, kind of some subspecialties in it, you know, that might be a consideration. But yeah, you do need to have the SMEs and the ontologists work together for sure.
Can somebody else find that document and paste it in the chat? Or I can, probably nobody else knows where it is.
What document?
Yeah.
Yeah, we can see a very nice link, but of course we can't click on it.
Right. Let me just get that link. I think the slides will probably be distributed, but just in case. Where is? Oops. The GIST style guide, by the way, is very much a work in progress. We are not, it's just in its infancy, so to speak. It's just something we work on as we go along. So don't think of it as a complete document in any sense. Okay. So again, a little bit of more nuts and bolts. You're probably familiar with the concepts TBox and ABox. So the TBox is classes and properties. The ABox is instance data. These are sort of industry standard terms, although I think they're losing popularity. Semantic Arts has its own term called CBox for the categories. And we follow a convention, which again is not yet implemented in GIST, but most likely will be. So we have whatever the ontology namespace is with a defined prefix. And for the prefix, we stick a D after that for instance data, and we could typically have a namespace like this one. And then for the categories, we stick an X on the prefix. And we would have a URI, something like this. Just a quick example. I'll try to go through this quickly. So the ontology terms have this MY prefix, and then we have a skill, which is part of the CBox, and a data is a person, is instance data. So it's in this namespace with a D. File organization, really quickly. We generally separate the CBox, the categories, from the ontology in a different file. I like to put each taxonomy into a separate file, even if they're small. Some other people will say if it's small, I'll just stick them all into one file, and only if I start getting really large ones will I put them in separate files. And knowledge graph organization would be similar. You would have different name graphs for the TBox, CBox, and ABox. And again, the exact same granularity issue would apply there, whether you want to have each taxonomy in a separate named graph or put them all together or something in between. I think we've only got 5 minutes left. It looks like I may need, I have some stuff I really don't want to skip, especially the open questions at the end, because I think that's one of the more interesting aspects of the presentation. So I think what I'd like to do is either take a few more questions before we end, or try to get through the next section before we end. So are there more questions or discussion points? Okay, sounds like no. So I'll try to go through this. So GIST also provides ways of structuring taxonomies or control vocabularies. So you can have a flat structure. So let me explain what we're doing here. This is the class, which is a subclass of category. So this is comparable to the skill class I had defined. And these are all they're all members of this class, and I have just I haven't drawn all the arrows here, but you can extrapolate. So each one of these things, sorry, this is not, I'm sorry, I've got a mistake here. This is not is member of, it's just a type, so I gotta fix that. Ignore just is member of, this should be RDF type. Again, we have this hierarchical taxonomy that we can build with GIST has super category, you know, where you have whole milk and skim milk, both have the super category milk and so on. And this can go down as many levels deep as you need to. We have the inverse predicate has subcategory, which goes down, from milk down to whole milk and skim milk. Now, usually in GIST, we try to avoid inverses, defining inverses, just because they complicate the ontology unnecessarily, and you can always do inverse queries, or you can add restrictions in OWL using inverses without defining them, using blank nodes. So we're moving away from transitive, all right, another mistake, this is inverse predicates. Sorry, before these get distributed, I'll make these fixes. So we're moving away from inverse predicates. So in fact, one of these may be deprecated or removed in a future release. So we tend to prefer the parent to child relationship which has supercategories. So we prefer going up the tree rather than down the tree. And why is that? So conceptually, dependency moves up the tree. So it's more natural to think of a relationship going from parent to child. So for example, the concept of milk can exist without the concept of whole milk, but not the reverse. So we tend to sort of think of, milk being the thing that this other thing relates to. And there's a very good pragmatic reason for doing it that way as well. Query performance will be better because there's only one trip, in most cases, only one triple linking up to a supercategory, whereas you would have potentially many links going in the downward direction. So essentially, if I'm, searching for supercategories of the supercategory of Emmentaler cheese, all I have to do is look up one step in the tree. If I'm looking for the subcategory of cheese, I have to go, there could be many results returned. So the exception to that would be polyhierarchies, where something can have more than one parent. But typically we don't work with those. So we also have a direct supercategory predicate, which is a direct link, and its transitive version that I've been showing you has supercategory. These work like Scosbroder and Scosbroder transitive. Right. So Emmentaler and Jarlsberg have a direct supercategory Swiss cheese. And Swiss cheese has the direct supercategory cheese, meaning by inference from the transitive relationship, Emmentaler has a supercategory of cheese. So that's built into the fact that these are defined as transitive. That supercategory is defined as a transitive predicate. Generally, we would prefer to define a direct relationship because making a stronger semantic claim, but we don't, it wouldn't always be correct to do so because we don't know necessarily if there are other things that might come in the middle. So it's safer just to define supercategory relationship. Okay, a little bit more, but we're out of time. So I'm going to stop here and hope to come back next month to finish this up.
Thank you for the presentation.
I take that when you say you're removing transitive categories, I mean removing transitive.
Sorry, but it was
removing
a mistake.
inverse properties.
That was a mistake. It's supposed to read inverse. Yeah, we're not removing transitive.
Right. Okay.
Right.
Thanks.
Okay, anything else before we wrap up? Okay, thank you very much for attending.
Thank you, everyone.
Thank you.